MAT1033 Final Exam Review Question 91. We have to state the property that's being used, and we have three examples. A is 5 times the quantity x plus 3 equals 5x plus 15. And what we have to determine is what property was used to change the left side to the right side. So if you notice, this 5 has been distributed as a product over the x plus 3, so it's the distributive property of multiplication over addition. Okay, that would be the name of the property that was used. In B, we've got 3x plus 1 equals 1 plus 3x. And again, how do we get the right side from the left side? Well, if you'll notice, the terms have actually switched positions. And that means that 1 switched places with 3x, or they commuted around addition. So this is the commutative property of addition. And then part C, we've got 5 plus negative 5 plus x equals 0 plus x. And again, we want to know, based on what we started with on the left side, what property allows us to rewrite it as the right side. If you notice, the only thing that has changed is that 5 plus negative 5 has been replaced by 0. Well, 5 plus negative 5, that's a number plus its opposite, so addition, additive, and those are inverses of each other. So this would be additive inverse. MAT1033 Final Exam Review Question 92. We have a problem-solving problem. Read the problem first. John has a jar in his room that contains 39 coins. Some are pennies and the rest are dimes. If the total value of the coins is $2.64, how many of each denomination does he have? Now, what we did when working with this type of problem solving is we created a table. We have pennies and dimes, so I'm going to use P and D, and then we had the denomination, so the decimal value, okay, 0.01, 0.10, and then the number of coins. Well, it tells us a total number of coins, so here we're going to have to use a variable. If x represents the number of pennies, then 39 minus the number of pennies would give us the number of dimes. That makes sense. And since we used x for the number of pennies, it'd be 39 minus x. And then the last column of the table, we had the value, which was the product of the first two columns. And that total value, the sum of those two values, would be our total amount of money. So our equation would be 0.01x, the value of the pennies, plus the value of the dimes, equal to the total amount of money. We end up with an equation containing decimal numbers, so we're going to multiply through by 100. Each one of the terms in the equation would be multiplied by 100. Don't forget to multiply all terms on both sides by 100. We would end up with 1x here, plus, now we're going to use the associative property of multiplication. We're going to associate the 100 and the 0.10. So we would end up with 10 to distribute over the 39 minus x, and then of course 100 times 2.64 is 264. Okay, let's distribute. So we've got 390 minus 10x is equal to 264. And then combining like terms, we have 390 minus 9x is equal to 264. We're going to subtract 390 from both sides. We end up with negative 9x, don't forget the negative, is equal to negative 126. And then we're going to divide both sides by negative 9. Here, remember, we let x be the number of pennies, so if we do not get a whole number here, we've got problems. And a negative divided by a negative is a positive. So we need a positive integer. We need a whole number here, or natural number. Now, x was the number of pennies, so my answer, because it asked me for how many of each denomination, we would have 14 pennies. And remember, we said that the number of dimes would be 39 minus the number of pennies, so we would have 25 dimes. If we check that real quick, 25 dimes is $2.50, 14 pennies is 14 cents, so $2.50 plus 14 cents is $2.64. So this checks out as the correct number of coins.